Okay, the third problem in our sample test is this function, to solve this equation. Okay, now that equation is pretty easy to solve. We just use the quadratic formula. If we can factor, we could factor it, and we can always complete the square and complete and solve this problem accordingly. This function, which I've written again here, is of the form ax squared plus bx plus c equals 0. It can be put into that form. Well, it's already in that form. The same equation could look like this. 4x plus 3x squared equals -6. If we add 6 to both sides and rearrange the order of the terms, we have this, which is in the standard form of the quadratic. Same here. If we add 6 plus 3x squared to both sides, we get the left-hand side. If we reorder the terms, we can put it in this form. Same here. Add 4x to both sides. We're going to get 0 on the right side in every case. You got to have 0 on the right side to be in the standard form of a quadratic so that you can apply the quadratic formula. And you also want it in standard form if you're going to do it by factoring or completing the square. Okay? And the terms could be all jumbled up. You could have -6 plus 3x squared plus 4x equals 0. You have to recognize in each of these cases that you have a quadratic function. And if you do, then it's a simple matter to rearrange it. And if all else fails, use the quadratic formula. Or if you just want to go ahead and use the quadratic formula. If you aren't asked to solve it by some specific method, it's totally up to you. The quadratic formula is often the default method. Now, quadratic equations aren't always in these forms. Turns out that this is a quadratic equation, as you would discover if you multiply by common denominators. So we multiply this by the common denominator, which is going to be 3 times 2 times x minus 2. Now I'm going to leave it in factored form. Of course, I could multiply out the 3 times 2 and get 6, and I could even multiply that through the binomial and get 6x minus 12, but I'm going to leave it in this form because then we're going to see much more clearly how everything works out. So we got 3 times 2 times x minus 2 multiplied by x over 2 plus 3 times 2 times x minus 2 multiplied by 3 over x minus 2 equals 3 times 2 times x minus 2 multiplied by 5/3. Okay, well, what happens here? This 2's in the denominator, this 2's in the numerator. The 2 divides the 2 and leaves us with 3 times x minus 2 times x. Here, the x minus 2 divides the x minus 2, leaving us 3 times 2 times 3. And on this side, 3 divides the 3, leaving us 2 times x minus 2 times 5. If we simplify this, 3 times x minus 2 is 3x minus 6. That's going to be multiplied by x. This is just plain old multiplication. We get 18. And 5 times 2 is 10. So we're going to have 10 times x minus 2. And if we use the distributive law again, we're going to get 3x squared minus 6x plus 18 equals 10x minus 20. Now, we see that we're getting close to the form of a quadratic, but we don't have 0 on this side. So we're going to have to subtract 10x and add 20 to both sides. I'm not going to write out an extra step for that because by now we should understand how that works. Minus 10x plus 20 And if we do minus 10x plus 20 on this side, we're just going to get 0. 10x minus 10x, 20 plus, negative 20 plus 20. Now we simplify this and we get 3x squared minus 6x minus 10x is minus 16x. 18 and 20 is 38. Now we have this in standard form of a quadratic, and we can use the quadratic formula, which we're probably going to need. If we try to factor 38, it's 19 times 2, and that's the best we can do. And I don't think that 19 and 2 is going to combine with the 3 to give us a negative 16. You could try it. So we would probably go with the quadratic formula and get our solution. Okay? Now, not every equation that you might get in this particular problem is quadratic. This equation looks a whole lot like this equation, but if we multiply by the common denominator in this case is going to be 2 times 3 times x minus 2, just as it was before. So we're going to have 2 times 3 times x minus 2 times 1/2 plus 2 times 3 times x minus 2 times 3 over x minus 2 equals 2 times 3 times x minus 2 times 5/2. And if we divide out the 2 here, we end up with 3 times x minus 2 times 1 plus x minus 2 divides the x minus 2. We got 2 times 3 times 3. And that's going to equal, 2 is going to divide the 2. Well, this 2 will divide this 2, right? And then 3 times 5 is 15. So that's going to be 15 times x minus 2. And I hope I'm doing this right. If I make a silly mistake, of course, you know to correct it. We get 3x minus 6 here times 1 doesn't change anything. We're going to get 18 here. We're going to get 15x minus okay, I did make a mistake. This should have been 5/3. So it's the 3 that should have divided out. And when we multiply that out, we're going to get 2 times x minus 2 times 5, which is going to give us 10 times x minus 2, which will make a 10 here and a 20 here. I wrote down a 2 here, looking out of the corner of my eye. Didn't get it right. Okay, so anyhow, when we simplify this, it should be clear that we're going to get negative 7x, subtracting the 10x, adding the 20, we're going to have 38, we're going to have minus 6. And we get a linear equation, whereas before we got a quadratic equation. The bottom line, the message here is identify your equation and solve it by an appropriate method. I don't know if you can read that word method. I kind of messed it up. Okay? Identify your equation, solve by the appropriate method. If it's quadratic, there are your methods. If it's linear, well, you know exactly what to do there. You got to subtract 32 from both sides, divide by minus 7. You get x equals 32 over 7. There are other kinds of equations, but right now you do well to get the idea in your head that there are a number of different kinds of equations. Here are 2 of them. Whatever your equation, you need to identify what kind it is and identify what method you need to solve it.